Hi everyone, this is lecture 1 on independent events. In the previous lecture, we talked about conditional probability, Bayes' theorem, and law of total probability. Now we are beginning to talk about independence of events. And just to give you a general idea, independence is a simplifying assumption, right? And we compute probabilities in a slightly different way if we know that two events are independent of one another. So let's look at an example first of all. Okay, so let's say we have this information given to us that A is an event, that it snows tomorrow, right? So we are given this information, and we also know that the probability that it snows tomorrow is 1/3, right? So this is some information given to us. Now assume that I toss a fair coin and B be that event, that head shows up. And also I know that the probability of heads showing up is 1 in this case. Okay. So what do you think is the probability of A given B? Right, so we have talked about conditional probability. We know that whenever we have additional information related to some event, for example, in this case A, given that B has occurred, what do you think is the probability of A given B? Well, if your guess was that probability of A given B is equal to probability of A, then you're correct, right? Why? Because the result of my coin toss does not impact tomorrow's weather in any way, right? So therefore, like no matter what happens, no matter what comes up in B, no matter what B is, the probability of A should not change, right? So this is an example of two independent events, right? So whenever we are solving problems that have two events or more, the important idea should be to figure out whether the events are related to one another or not. And based on that, we compute probabilities, right? Okay, so here is the formal definition of independence. Events A and B, any two events, are independent when they have nothing to do with each other, right? So this is the easiest way of understanding two events are independent, just like we had the example on tomorrow's weather and tossing a coin, right? Now, knowing the outcome is in B does not change the probability that the outcome is in A, right? This is what exactly this is what happened in our example of tossing a coin and tomorrow's weather. So the event, if we know that A and B are independent, then probability of A and B, which we obviously denote like this, is probability of A times the probability of B, right? We know this equation from our definition of conditional probability. The only thing that has changed here, so remember this was the definition of conditional probability, A and B over probability of B, right? So let's say if I was and this comes from the multiplication rule, remember? So if I'm interested in probability of A and B, and I know that both A and B are independent, so that means this term here changes to probability of A, right? Which is why I get probability of A times probability of B, right? So independence essentially means probability of A given B is nothing but probability of A. And this is a non-trivial assumption. This really matters when you're deciding to compute probability of two or more events, right? And also you cannot always assume it. And we have seen in plenty of examples when we were talking about conditional probability that we cannot all the time assume it. But whenever we can, then the probability of A and B is actually the probability of A times the probability of B, which means we just multiply the probabilities, right? So it really makes our life easier. Okay, sorry about this. Okay, so this was the definition of independence in general. Let's look at some examples, right, to better understand what independence is. Okay, so suppose a fair coin is flipped 3 times, right? Does knowing the first flip comes up, tails, alter the probability that tails comes up an odd number of times? Okay, so So let me actually write down the events here. So let's say A is my event that a fair coin is flipped. Or let me say if not A, let me have it E and F, just like to stick to what we have used in the previous video, right? So let me just get rid of this. Let me get the pen back. Okay, my pen, right? So let F be the first flip comes up tails, that's event F, and tails comes up odd number of times would be E, right? So first flip tails, and tails comes up odd number of times is E. So that means tails comes up either one time or three times, right? Okay, so these are the two events, right? So the question is whether the probability of E given F equals the probability of E, right? That's what the question is asking us. So let's determine that, right? We know how to determine, let's determine the probability of E, right? Okay, what are all the possible cases of having a coin flipped three times, right? So this is my sample space. Each can take two values, and so that's my total sample space. That's 8, right? 2 to the 3, that's the total sample space. Now, so I'm interested in the event E, which means either tails comes up one time or three times, right? So this is either 3 choose 1 plus 3 choose 3, right? Which is equal to 4. Correct? So the probability of E would be 4 over 8, which is 1 over 2. Right? Now I need to get the probability of F. Okay, so the probability of F first flip is tails, right? So the first flip, that means like this is 3 tosses, right? Tail must come here no matter what happens here, right? So there are how many ways of having this? 4 out of the total of 8, right? Which is again 1 over 2, right? Now I'm also interested in finding the probability of E and F, because then only I can prove whether they are independent or not, right? So probability of E and F is when both of them overlap, right? So how can we get E and F? Which means tails comes first, right? First flip is always a tails, and then tails comes odd number of times. So there are two such cases, right? Two of them out of all the 8 when E and F. That's my cardinality, right? So then two such cases, because there will be a fixed tails already, and then odd number of times means either 1 or 3, right? So 2 of those. And so my E and F is 1/4. Therefore, what is my probability of E given F from the formula? We know that probability of E given F is probability of E and F, which is 1/4, over the probability of F, which is half. And so this is 1 over 2, right? And so if we look at it, my probability of E is 1 over 2, and my probability of E given F is also 1 over 2. So my answer is yes for this question, right? So knowing the first flip comes up tails, essentially this is true, right? So the events are independent. Okay, let's actually look at another example to better understand what independence is, and I'll continue with that example in the next video.